Hello everyone. So today, as you can see this heading, it is written here Lewis structure of aluminium trifluoride, which is AlF3. Al is aluminium and F3 is three fluorine groups, that is trifluoride. So together the name is aluminium trifluoride. So let's look at the Lewis structure of this particular compound. So first you have to understand here is that aluminium, you have to know in which group it is. As you can see here, aluminium is in the 13th group. That means it must be having 3 valence electrons. So first let me write the central metal atom, that is aluminium, and as you have seen here just now that it is in the 13th group, so it must be having 3 valence electrons, just like boron or gallium or indium in the respective groups. Like 13th group will have 3 valence electrons, 14th group will have 4 valence electrons, so that so on you have to know. So for this example we are discussing about aluminium metal, so it is in 13th group, so we should have 3 valence electrons. So now let me draw 3 valence electrons over here. And aluminium trifluoride, that means one is a metal and another one is non-metal, so this must be an ionic compound. So ionic compound, the metal tend to lose electrons, and let me write that the metals lose electrons whereas the non-metals gain electrons. So in this example, aluminium, as you know, which is a metal, will definitely lose electrons. It will donate its electrons to fluorine. So by the way, in which group does fluorine exist? Look at the 17th group. Oh, here it is. The first one of the 17th group is fluorine only, and followed by chlorine, bromine, iodine and astatine, so on. So this 17th group will have 7 valence electrons. So let me draw fluorine F, and let me do this with another color. Yeah. So fluorine should have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. But is this completed? No, this is not completed. Still there's a long way to go, because the formula is AlF3. So there should be 3 fluorines. So for another fluorine also the same. Let me draw 3 fluorines over here, and then for each fluorine there will be 7 valence electrons, because this is from the 17th group, the group which is just beside to the noble gases. So now 3 fluorines, what they want these fluorines is that if they get one more electron, they can achieve the noble gas configuration. As you know, in the 18th group, the noble gases, they are completely stable, they have fully filled valence electrons. So that's why this 17th group, they want to achieve noble gas configuration too. So that's the reason why they want to gain one electron from aluminium. Since aluminium has 3 electrons, and here there are 3 fluorines, so each fluorine will need 1 electron. So definitely 1 electron of aluminium will go to this fluorine, another electron of aluminium will go to this fluorine, and this electron of aluminium will go to this fluorine. So now what happens is that one aluminium has given its 3 electrons to 3 different fluorines, and if you can read the formula here, it is AlF3. So compulsory one aluminium is only there, you cannot add more, and there are 3 fluorines. You have to satisfy all the 3, because they have to achieve their noble gas configuration. And as I have already told you, when they have gained electrons, that means they'll become negatively charged, and then when aluminium has donated the electrons, that means it is positively charged. Since aluminium has given 3 electrons, it will become 3 plus, and F 1, 2, 3, 4, 5, 6, 7, 8. Wow, it has attained noble gas configuration. But wait, what about the charge? Since it has attained 1 electron from aluminium, I mean talking respectively of each fluorine, this fluorine has attained 1 electron. So let me draw -1 here, because it gained 1. But it is not finished here. There are still more 2 fluorines we need to draw. 1, 2, 3, 4, 5, 6, 7, 8. And this also gets minus 1. And even this fluorine, this also gets minus 1. So aluminum ion has plus 3 charge and 3 fluorines together will have also minus 3. So it is completely, this compound is stabilized because this has given 3 and this has gained 3. So even if you see here minus 1, minus 1, minus 1 sums up to minus 3. And then here this is plus 3. So that's how you have to draw the Lewis structure of aluminum trifluoride. I hope you have understood it better. And then if you have any doubts, you can ask me in the comment section down below. Please don't forget to visit our Facebook page. Thank you so much. Please leave a like down below if you liked my video. Please don't forget to subscribe to my channel. Thank you.